Hello everyone and welcome back to my channel. In today's video we are going to solve practice problems 2.9, 2.10 and 2.11 from chapter 2 of our textbook. These examples will help you better understand the basics of circuit analysis like Ohm's law, power and how to combine resistors in series and parallel. Before we begin, here is a quick reminder. Resistors are in series when they are connected one after another and shared only one common node. For example, in this example, you can see that they are only sharing one node, 8 ohm resistor with 10 ohm resistor. Therefore, they are in series, or 10 ohm resistor sharing one node with 6 ohm resistor. Therefore, these three resistors are in series, and I can write 8 plus 10 plus 6, which is equal to 24 ohm. And resistors are in parallel when they are connected to the same two nodes. This means they have the same voltage across them, but the current is split between them. Okay. So, very soon I will explain over here what is happening to my circuit. Let's redraw the circuit knowing that these three resistors are in series. I can replace this circuit by the following circuit. 4, 3 ohm. I have 4 ohm resistor. Here I have 12 ohm resistor. And the substitute one is 24 ohm. Now you can see that these two resistors, I mean 24 ohm resistor and 12 ohm resistor, are in parallel, since both of them using the same two nodes. This is, if we call it node A, this is also node A. If we call this one as node B, this is node B. Therefore, 12 is parallel to 24. Therefore, we know for the parallel resistor, we have the product of them over the sum of them, which is 12 plus 24. If you calculate, it's going to give you 8 ohm. Now, I can redraw my circuit. I have 4 ohm here, 6 ohm here, 3 ohm here, 4 ohm here, and this is going to be replaced by equivalent resistor with 8 ohm. Now you can see that this 8 ohm, since they are only sharing one node, is in series with 4 ohm resistor. 8 plus 4 is give me 12 ohm. And later on we will see that for this circuit we're gonna have 4, 6 and 3 ohm, which is parallel to 12 ohm. Now we see that these two are parallel again, since they are using the same two nodes. Therefore, we know that for the parallel resistor, this is the product of two resistors over the sum of two resistors, which gives me 4 ohm. And finally, we're gonna have a circuit like this, 4 ohm. So let me change the color. This is the original circuit, 4 ohm. This is 3 ohm, and the summation of these two was 4 ohm. Now all these three are in series because they are using this only one common nodes. Therefore my R equivalent here is equal to 4 plus 4 plus 3, which is equal to 11 ohm. Now I'm going to solve another example. You also can think of this one to see how it works. First of all, I can start from upside. You can see that 20 ohm resistor is in parallel with 5 ohm resistor because both of them using the same two nodes. So I can start with this one, and 20 with 5 over 20 plus 5, which gives me here 4 ohm. Okay, so what can I do? I can remove this one and replace these 4 and 5, which were in parallel, by one equivalent resistor, resistor, which is equal to 4 ohm. Now this 4 ohm plus 1 ohm are in series because they are using only one common node, which gives me 5 ohm. Therefore again I can replace this side of my circuit by one equivalent resistors with 5 ohm. Now what is coming next? Now I can see that these two resistors, 5 ohm resistor and 20 ohm resistor, again both of them are using the same two nodes. Therefore again they are in parallel. So 20 in parallel with 5, again 20 plus 5 is give me 4 ohm. Okay, meaning that again I can replace this circuit by an equivalent resistance of 4 ohm. Now if you look at this one, you can see that 4 ohm resistor with 2 ohm resistor, they are in series because they are using only only using one common nodes. Therefore what can I say? I can say that these two are in series. Therefore 4 is in parallel in series with 2 is give me 6 ohm. So therefore what can I do? I can replace this circuit by an equivalent resistors that is 6 ohm. Now if you look at here, 6 is in parallel with 1 because both of them sharing the same two nodes. Okay, if it is A, this is A. If it is B, this is also B. Therefore, what can I say? I can say that 9 times 6 over 9 plus 6, which if you calculate, it is equal to 3.6 ohm. Okay, therefore again I can replace these two resistors by a resistor by equivalent resistors that is 3.6 ohm. Now what is happening next? Again, if you look at this one, there are again sharing the same nodes. If I call it A, this is B, this is B, so meaning that 3.6 is in parallel with 18. That means product of 18 times 3.6 over the summation of 18 plus 3.6, which gives me 3 ohm. Therefore, I can replace again these two as an equivalent with, we find it as 3, yeah? We find it as 3 ohm. Therefore, what is my R equivalent? My R equivalent is equal to 16 plus 3, which is equal to 19. You can see very complicated problem can be solved easily. Now, solve the last question, the last problem, problem 2.11, is asked you to find the conductance, equivalent conductance. What we know about about the conductance? Conductance is the inverse of resistance, meaning that if two conductors are in parallel, we should add their value. So, like here. So, here these two are in parallel, because they are using the same two nodes. If it is A, this is A, both of them same node. Here B, B, they are using the same node here. Also C, C, meaning that 7 Siemens and 5 Siemens are in parallel. So the total, I call it G1, the equivalent part of this one will be 7 plus 5, because for the parallel we should add them up, which is equal to 12 Siemens. Again, here you have 16 Siemens and 8 Siemens. So again, they are using these two conductors using the same two nodes, therefore they are in parallel. Parallel for the conductance means you are going to add them up. So G2 over here is 16 plus 8, which is equal to 24 Siemens. And obviously, if I redraw this circuit, I end up with 12 Siemens in series with 12 Siemens. And if two conductor is in series, the equivalent conductance can be found as this is 24, the other one 24. If two conductors are in series, the equivalent conductance can be found as product of them, over the sum of them, which over here going to be 8 Siemens. And that's for today's video. We solved the problem 2.9, 2.10 and 2.11, and along that way we learned more about how to work with the resistor in series and parallel. If you found this video helpful, please like and subscribe, and feel free to leave a comment if you have any question or topic you'd like to see next. Thanks for watching, and see you in the next one.